2023 Special Exam 2. I've heard that it's not too bad, but I did hear that the last question has a mistake, so it'll be interesting to see how bad that mistake is. Now, we'll get right into the multiple choice. I might make mistakes, so if I do make any mistakes, please just let me know in the comments. Because this is my first try. So, the first one is a proofs one. Consider the following statement: if my football team plays badly, then they are not training enough. Which one would be the contrapositive? So if P implies Q, then the contrapositive is not Q implies not P. So not Q would be the opposite of not training enough, which is probably training enough. So this one, not that, not that, not that. So C or E, and then not P. So that means they are not playing badly. So then my football team does not play badly. So C would be the answer for that. The graph has asymptotes given by y is equal to that and that. The values of A, B, and C are respectively. You could probably try and solve for A, B, and C, but that's going to take way too long. What you can just do is just test the answers. So what I would do is just define the answer, the x cubed x cubed over, and just define as your first answer option first, so 2x squared minus 4x plus 2. And then just do an expand and see what the asymptotes are. You've got the x is equal to 1, but you've got this one isn't y is equal to 2x plus 1. So just enter this f of x down and change the a's, b's, and c's. So 1/2 -1/4 and -1/4 again. And then just enter the same expand. Okay, so you've got x is equal to 1, you've got y is equal to 2x plus 1, but you've got this extra x is equal to -1/2. Now it doesn't say only has asymptotes, and these do have both of those asymptotes, they just have an extra one, so I'm hoping the other ones don't only have those two, but then that should just be a mistake in the question. They would have to say only has asymptotes given by those two. Otherwise, B is also correct. In the interval -pi to pi, the graph of y is equal to a sec x has 2x intercepts when. So for these questions, again, of course you can solve, but I think it's just easier if you just use a slider. So what I'm going to do is go to the graphing page, sketch a plus sec x, and create your slider. And I should have put the domain. So -pi is less than or equal to x, which is less than or equal to pi. Oops. Okay, so these are our two. Now just test your answer option. So it already has two x-intercepts when a is 0, so 0 should be in one of the answers. So you can eliminate e, because there's no 0. Here there's no 0. Here there's no 0. So it's already between a and b. Now the way we can test that is if we just try -1, because that would, if -1 doesn't work, then we've ruled out b. So a is, I'm just going to write it. -1 isn't included, but let's just try a negative number. So here we've got 1. Oh, that's at -1. Let me try -0.5. Here we don't have any. So it looks like we can't have that. Let me just confirm that the answer is A then, and just put in 0. Oh, 0 was correct. Let me try anything bigger than 0, so maybe 0.5. Oh, we still don't have two x-intercepts. Maybe I've made a mistake. Oh wait, 0.5. 2x-intercepts. Oh, sorry, I ruled out option E, which does... No, it doesn't have 0. What have I done? -1 to 1. Just double check that again. If I go down to negative, that's -1.5. So that's got 2. So we want it to be, I guess, yeah, here you want it to be less than -1, right? Because -1, you've got 1, but anything less than -1, not including -1, is part of it. So less than -1, that's got E. Not less than or equal to -1. I guess that just means the answer is E. But let's check that as well to check if greater than 1 also works. So here we've got 1, that's 2, and so on. I looked at the option when A was 0. I said A was 0, but A was actually 1. So that was the mistake I made. So yeah, the answer is E here. If Z is equal to -2a plus 1 plus 2ai, where a is a non-zero real constant, then 4a over 1 plus z is equal to the conjugate of z. So can we make this a polar form? Alright, let me just define store z as that. Actually, I'll just write it out. So 4a, a is defined as my slider. So 4a over 1 plus, the conjugate of z would be negative. So I'll just write 1 plus, and then I'll write negative 2a plus 1, and then minus 2ai. And that's -1 plus I. So that's the magnitude is √2. So you can eliminate C and E. And -1 plus I would be here. So that's going to be 3 pi and 4, I think. So √2 is 3 pi and 4. Alright, let Z be a complex number where real of Z is greater than 0 and imaginary is so it's in the first quadrant, is what they're saying there. Given that the magnitude of Z is 4 and arg Z cubed, the angle for Z cubed, is -pi. So what this means, well, that doesn't make sense because that's wrong. That's a mistake because the argument of Z should not be, -pi is not included. It should be pi. That's fine. So the magnitude is 4 and it's over here if you cube it, right? So if it's in the first quadrant and then they want Z squared is equivalent to alright, so square root of x squared plus y squared is equal to 4. Or you can say 4 cis theta, and you can say that 3 theta is equal to pi, so theta is equal to pi on 3. So this is 4 cis pi on 3, and 4 cis 2 pi on 3 for z squared would be 16. 16 cis 2 pi on 3, and that is what? 4, okay, so initially we found that it's going to be 4 cis pi on 3. Now if you multiply this by 4, that's wrong. It should be, if it's 2 pi on 3, then sine is positive, and that I think should be E, because cos is negative, so -4, and then cos of the conjugate would be the same thing. Yeah, I think the answer is E here. Yeah, should check that, but yeah, I think it's E. Consider the following pseudocode defined that. After how many iterations will the pseudocode print that? So I think this is doing Euler's method. And the function is e to the power of x times y. So I'm just going to go to the CAS for this. And here we've got e to the power of x times y. And the first value, so it's the x0 is 0. So the first iteration is going to give you, so let's just write it out. The first iteration is when you plug in 0 plus 1/2, and then e to the power of x times y, so 0 times 0. So that's going to give you 1/2. That's the first one. The second iteration is the new y, which is now 1/2, plus 1/2 times f of. Now this has moved up by 1/2, so e to the power of 1/4. So 1/2 times 1/2. So what's that? 1/2 plus e to the power of 1/4, and 1/2 times e to the 1/4. And that is 1.14. So now it's going to be 1.14 plus 0.5 e to the power of, now x has become 1 because 1/2 plus 1/2, and y has become that, and that's the 2.709, and that's after the third iteration. Okay. 7. The direction field for a differential equation is shown above. On a certain solution curve of this differential equation, y is equal to 2 and x is -1. So -1, 2. So that would be looking like something like that. The value of y on the same solution curve when x is equal to 1.5 is there, would be about 1. If I've done that right. Yeah, it's about 1. Initially, a spa is filled with 8,000 liters of water that contains a quantity of dissolved chemical. It's discovered that too much chemical is contained in the spa pool water. To correct the situation, 20 liters of well-mixed spa pool water is pumped out every minute, while 15 liters of fresh water is pumped in each minute. So let's just draw something. Oops. So 8,000. And basically what's happening is you want dq dt. So that's dq over dv times dv over dt. Now dq dv, that's the ratio or the rate of change of the mass over the volume. So the mass is at any time they've told us is q. And that's over the volume at any time. Now the volume started off as 8,000 liters, but then you're minusing, so you've got 15 coming in and 20 coming out. So you're at a net loss of 5 liters per minute t. And so that's dq dv. Now dv dt, that's in relation to q only. So you're losing 20 liters of the because you're inputting 0 technically dq over the volume of the concentration of the solute. So you've got to multiply by losing 20, I believe. So that's -20 q over 400 minus t. Is that right? 5 into 80. 5 into 80 is 1,600, not 4. Minus t, and that is negative 4q on 1600 minus t. So if you cancel the negative, that gives you a. Position of a particle moving in the Cartesian plane at time t is given by the parametric equations. What is the slope of the tangent to the path of the particle when t is 2? So you want dy dx basically. Now that's dy on dt times dt on dx. Or you can say y dash of t times by 1 on or over x dash of t, and that is all when t is equal to 2. So just go to your calculator, put a fraction. The derivative of y was on the top, derivative with respect to t, sorry, of y, so this was negative 8 on t squared plus 4. And then over the derivative of x, which was 6t over t plus 1, and that's all when t is equal to 2. You get 3/4, and that's d. Question 10. Integral of n is equal to that integral where n is equal to n is a number of natural numbers. Then for n is greater than or equal to 1, I of n is equal to that. So first, this is integration by parts. So you're trying to find a reduction formula. So if you just do di plus minus, you want to differentiate the 1 minus x to the power of n, assuming that that will end up with a power of 0 sometime. Integrate e to the power of x. So that stays the same, and this here becomes, when you differentiate this, you get n 1 minus x to the power of n minus 1 times negative 1. So this works out to be e to the x times 1 minus x to the power of n minus or plus the integral, and you can take out n, of 1 minus x to the power of n minus 1 e to the power of x, and that's from 0 to 1. This is also from 0 to 1. So you plug in 1, you get e, and then 1 minus 1 to the power of anything is 0. So it's just 0. This works out to be 0. And then this is n times, and it just looks like the n has swapped with n minus 1. So I of n minus 1, n times I, that's that b. Alrighty, the area of the curved surface generated by a revolving part of the curve with equation cos inverse to form from 0 to pi of 2 to 1, 0 about the y-axis. So I can't really remember the formula, but I think it is the integral from a to b of, so if it's about the y-axis, then it would be 2 pi x times the square root of 1 plus dx on dy dx or something. Let me just get the formula. Alright, so formula sheet here, and the surface area about y-axis, Cartesian, is, did I get it right? What did I get? 2 pi x times the square root of, very close, 1 on, sorry, it's 1 plus dx on dy, or squared dy. So, and a to b, so is just y1 to y2. So this is y1 and this is y2. So if you just put that on the formula sheet, this is going to be 2 pi. Oh, so they haven't even done the answer. So let's see. 2 pi times pi over 2 to 0. And now x is, what was x? X is cos of y times the square root of 1 plus sine squared because the derivative of cos y is negative sign, but squared is just positive sign squared. And that's dy. Now, that's the integral from pi over 2 to 0 of 2 pi. You can automatically eliminate these because that's just wrong. That also looks about wrong. So it's going to be the substitution. If you can't be bothered figuring out the substitution, just sub this into the cas and then sub these into the cas and see which one gives you the same thing. Otherwise, it looks like your bounds are going to change if you sub in sign. So they shouldn't stay as 0 to pi over 2. They should change to 0 to 1. So I'm just going to choose E. That's what I would do on an exam. I wouldn't waste too much time. But just to confirm, if you sub in U is sine y, when y is pi on 2, then U is 1, and when it's 0, it's 0. So 0 to 1. And I'm assuming that you've got a negative somewhere or something like that. So E should be the answer. The acceleration a meters per second squared of a particle that starts from rest and moves in a straight line is described by a is equal to 1 plus v, where v is its velocity after t seconds. The velocity of the particle after that second is, so v dv over dx is equal to 1 plus v. dv on dx is equal to 1 plus v on v. dx on dv. What am I doing? Velocity after. When t is that. Is that right? Just get the formulas. So I made a mistake. Well, I didn't use the wrong formula. So dv dt is equal to 1 plus v. So dt on dv is equal to 1 on 1 plus v. And the initial starts from rest. So initially the velocity is 0. So you can say, you can solve for t. That's the integral from 1 of 1 plus v dv. And that should just be ln of absolute value of 1 plus v plus c. And initially the velocity is 0. So t is 0, v is 0, c is 0. So when t is log base e of e plus 1, that's equal to log base e of v plus 1. V must be e. A tourist in a hot air balloon which is rising vertically at 2.5 meters per second accidentally drops a phone over the side when the phone is 80 meters above the ground. Assuming air resistance is negligible, how long in seconds? So this is SUVAT, so to hit the ground. So initially your S is, so you want your S to be negative 80. And so I'll just write the formula. S is equal to, what do we have? We have the initial V, so we have U. We have S, U, and we also have A, which is just negative 9.8. And what do we want? We want T. So we want an equation with all of these S, U, A, and T, something without velocity. So that would probably be S is UT plus 1/2 AT squared. So negative 80 is equal to 2.5 times T minus 1/2 times 9.8 is 4.9 T squared. And just solve that on the CAS. Menu 3.1. Negative 80 is equal to 2.5 T minus 4.9 T squared, comma T. T is 4.86. which is none of the answers. What have I done? Oh, we can just, so maybe if it's 0 then. No, but that doesn't have. No. 80 meters above the ground. Oh, I think this should be a positive. Oh, I wrote 3.9. That's why. 4.9. And that's 4.30, which is me. Let A be that, and C be that, and B be that. If n is a unit vector such that A dot n is equal to 0 and B dot n is equal to 0, then C dot n is equal to. Okay, so let's just say these are in 2 dimensions. So you just want the magnitude. So this is perpendicular to both, right? So if that's I, that's J, then this has a third, it must have a third dimension, and it's a unit vector. So the magnitude of C dot n, this must just have a k component, and it's 1. So it should just be 3. So the reason why is because these are both x and y's, or I and j's, and if it's perpendicular to both, because the dot product is 0, then that goes in that third dimension, and it's a unit vector, it has a magnitude of 1, so it only goes in that k direction. Oh, I guess it could be somewhere here, but I'm guessing it's just going to be 3. Yeah, that's my guess. If the sum of 2 unit vectors is a unit vector, then the magnitude of the difference of the 2 vectors is. So if the sum of 2 vectors, so like that, is a unit vector, that has a magnitude of 1, that has a magnitude of 1, that has a magnitude of 1. So 60 degrees, 60 degrees, 60 degrees, it's an equilateral triangle. So I might just draw that. Now, if we want the difference of the 2 vectors, so let's say these were our 2 vectors, then we basically want this magnitude here. So this is 120 degrees, this is 1, this is 1, so we can use the cosine rule to find b, and the cosine rule is c squared is equal to a squared plus b squared. I can't remember if it's plus or minus 2ab. Minus 2ab, cos 120. Cos of 120 degrees is, what's 120? So it is 120 times pi on 180 is 2 pi on 3, and that's 1/2. Multiplied by 1, that's 1. So that's 1 plus 1 minus 1. Plus 1. So that's root 3. The student throws a ball for his dog to retrieve. The position vector of the ball relative to an origin O at ground level t seconds after release is given by that. Displacement components are measured in meters, where I is a unit vector to the east, whatever. K is vector vertical up. So K is vertical up, and I want the total vertical distance traveled by the ball before it hits the ground. So, looks like it starts at 1.5 off the ground, and then it probably goes something like that because it's a parabola. So we need to find this maximum. It goes up that distance, down that distance, and then an additional 1.5 to the ground. So let me just do f max of that function, and 15x minus 4.9x squared plus 1.5 comma x, and that's that. So I just need to figure out what that is. So 12.97 is the maximum, but remember, so we need to 12.97. So it goes up 12.97 from 1.5. So it goes up that distance and then plus the 12.97. Yeah. 24.45 or 24.5 D. Question 17, consider so many vectors, and even the next one. Consider the vectors that where A and B. If A cross B is C, then that. Okay, so what I can probably do, or hopefully do, is define this vector. I'm just going to say A, actually I can't say A, let me just say X, Y, and Z are my alpha, beta, and gammas. So X, comma, 1, comma, negative 1. I'm going to store that as my vector A. Then B was 3, Y, 4. And my C is 2, negative 7, gamma, which is Z. Then it's saying cross product of A and B is C. So solve cross P of A comma B is equal to C. Will that give me all of them? Nice. So X alpha is 1, beta is negative 2, and gamma is negative 5. That looks like C. The value of K, where that is, and that will make the following planes perpendicular. So that's not too bad, because if they're perpendicular, then even the normals to the planes are perpendicular. So 2i minus kj plus 3k dot 2k plus 2ki plus 3j minus 2k. That should be equal to 0. So 4k minus 3k minus 6 is equal to 0. K is equal to 6, I think. Hope that's right. 19. A company accountant knows that the amount owed on any individual unpaid invoice is normally distributed with a mean of 800 and standard deviation. So O is normally distributed, mean is 800, standard deviation is 200. What is the probability that in a random sample of 16 unpaid invoices, the total amount owed is more than 13,500? So E of, remember this is not just 16O, it's O plus O plus O 16 times. So your expected value would just be 16 times 800. But your variance is, it's not 16 squared times 200 squared, it's just 16 times by 200 squared. And so your 16O or whatever is normally distributed with 16 times 800, and the square root of 16 times 200 squared all squared, and you want the probability that 16O is more than 13,500. Alright, let's see what that is on the Kaz. So menu 552. You want 13,500, and your upper bound you want to be infinity. Now your mean was 16 times by 800, and your standard deviation is the square root of 16 times by 200 squared. 0.1907 or 0.191 B. The lifespan of a certain electronic component is normally distributed with a mean of mu and a standard deviation of standard deviation. Given that 99% confidence interval on a random sample of 100 such components is that. So we can make a confidence interval to simultaneous equations. So menu 371. Actually, first we'll probably get the z value for a 99 confidence interval. So menu 55. We're doing an inverse normal. So that's 3. And then it's going to be 1 minus 0.99 over 2. So that's your z value, 2.57. And you can do menu 371. You're solving for, I guess, p hat or whatever, x bar, and your standard deviation, which I'll say is s. Now, the first equation is going to be your p hat minus minus this value times by the standard deviation over the square root of n, or the square root of 100. That's equal to 10,500. And your p hat, I'll just copy and paste this exact thing. I think I wrote that down wrong. So it was 10,500, not 1,500. And then p plus 2 point that is equal to 15,500. And you can solve there, and you get your standard deviation is 9705. So closest to 9710. So that's the multiple choice. To be honest, it is quite long. And there are some questions that they don't usually ask, like they didn't really ask about this ever. This as well. Of course, there's the new stuff. What else was pretty annoying? I didn't really like the differential equations question, but the rest I think was okay. But just remember not to spend too much time on multiple choice questions if they're pretty bad. Just move on. They're worth 1 mark, and your extended response is worth a lot. So I'll move on to the extended response. Viewed from above, a scenic walking track from point O to point D is shown below. Its shape is given by that. The minimum turning point of the section OABC occurs at point A. Point B is a point of inflection. The curve meets at point C10. Distances are measured in kilometers. Show that A is -1 and B is equal to 0. So, well, it's a turning point, so, okay. So what we can do is you can say f dash x for x is an element of 0 to 1 is equal to, actually, you can, what am I doing? You can just plug in 1, 0 there. So f of 1 is equal to -1 times 1 plus a squared, and that's equal to 0. So that means a is equal to -1. And for b is equal to 0, what else did they tell you? Well, it joins at c. So also e to the power of 1 minus 1 minus 1 plus b is equal to 0. So 1 minus 1 plus b is equal to 0, b is equal to 0. Verify that the two curves meet smoothly at point C. So, of course, negative x times x plus, it was minus 1 squared at x is equal to 1 is equal to 0. And that looks a bit weird. Let me just... And also, e to the power of x minus 1 minus x at x is equal to 1 is equal to 0. So they join. Now we just need to show that they join smoothly. So the derivative of negative x times x minus 1 squared at x is equal to 1 is equal to, and we can use the cas for that. So shift minus dx, and then you've got negative x times by x minus 1 squared, and that's at x is equal to 1 is equal to 0, and then d over dx of e to the power of x minus 1 minus x at x is equal to 1. I'm just going to say is equal to 0. Well, it has to be. So, therefore, they join smoothly. Find the coordinates of point A. It doesn't say, yes, I just said that. Find the coordinates of point A. It doesn't say you need any working out. There's only 1 mark. So you can just do solve. This is equal to 0 comma x, and it's at 1/3. And then you can plug in 1/3 here. And that's negative 4 on 27. So A is equal to 1/3 negative 4 on 27. Find the coordinates of point B. It's still 1 mark, so you can just solve the double derivative. So the derivative of this is equal to 0 comma x. X is 2/3. Then you can plug in 2/3 here and get negative 2 on 27. 2/3 negative 2 on 27. Yep. The return track from point D to point O follows an elliptical path given by that. Find the Cartesian equation. So x minus 2 over 2 is equal to cos of t. Y over e minus 2 is equal to sine t. That's new. X minus 2 squared on 4 plus y squared on e minus 2 squared is equal to 1. Sketch the elliptical path from D to O on the diagram on page 10. Where's page 10? Is that here? 10, yes, this is 10. So the center of the ellipse is 2, 0. And then you go back e minus 1. So your x, your horizontal thing is 2, semi-radius or whatever it's called. So that's here, and they didn't show, is it 2? Yeah, it looks like 2. Did I do that right? Yeah. Why can't I sketch that? It should be about there. Does it have, it probably has restrictions then. From pi over 2 to pi. So this only goes from here to here. So it's only negative. So it's only negative parts of x. So you're only, what's your starting and finishing point? Your starting point is pi over 2, which this is 0, is x is equal to 2. I must have made a mistake. What have I done? And then when x is equal to 2, y is equal to its maximum. So that's just going to be e minus 1. And does it say it intersects with d? Is that e minus 1? The turn track from point D to point O. So yes, so that's the starting point. And I'm guessing it's literally just this. Yeah, well that's, I don't know why. And you need direction, so it'll be like that. Yeah. Alright, write down a definite integral that gives the length of the elliptical path from D to O. So that would be the integral from pi over 2 to pi. So I'm just going to do the parametric, because I can't be bothered finding the x and y's, even though I've already gotten it. But here you've got dx dt squared, so you can say negative 2 sine t squared, so you can say 4 sine squared t. That's the derivative of x with respect to t, and then plus e minus 2 squared cos squared t dt. Find the length of the elliptical path, give you answer in kilometers. So let's just evaluate that integral. Shift plus for an integral, pi on 2 to pi. You've got the square root of 4 cos t, sine squared t, plus e minus 2 squared times by cos t squared dt, and that gives us 2.25 kilometers. Question 2, so that was a nice question, not too bad. Verify that w is a root of that. So if you put in cis 2 pi on 7 to the power of 7 minus 1, that's equal to cis 7 times 2 pi on 7 minus 1, and that's cis of 2 pi minus 1, which is 1 minus 1, which is 0, which is the right hand side. List the other roots of z to the 7 minus 1 in polar form. So if this is 1, then you can basically keep adding 360 divided by 7, or 2 pi on 7, to these until you get principal, and you should have 7. So you can have cis 4 pi on 7, you can have cis 6 pi on 7. You can't have anything more than that because you'll go over the principal argument. So now you go from 2 pi on 7 and minus 2 pi on 7, so you've got cis of 0, then cis of negative 2 pi on 7, cis of negative 4 pi on 7, cis of negative 6 pi on 7. 1, 2, 3, 4, 5, 6, and our 7th is there. On the Argand diagram below, plot and label the points that represent all the roots of 2 to the power of 7 minus 1 is equal to 0. So first of all, you've got cis of 0, and that's just 1. And then, what are these angles? 30, 60, no, I think they've divided it up as 7s, so pi on 7s for you. So what's pi on 7 as an angle? So pi on 7 times by 180 on pi is 7 into 18, which is 20 point something. So yeah, it looks like these are all pi on 7s. I'm hoping. Otherwise that would be quite mean. So you've got cis 2 pi on 7 is the next one. Then add another 2 pi on 7, which is here. Add another 2 pi on 7, which is here. Another 2 here, here, here. Alright, so you have to label them all, which is a little bit annoying. So this is cis 0. Here is cis 2 pi on 7, or W. Cis 4 pi on 7. Cis 6 pi on 7. Now keep in mind that these now go in the negative direction. So this is cis negative 2 pi on 7. Cis negative 4 pi on 7. And cis negative 6 pi on 7. Okay. On the diagram below, sketch the ray that originates at the real root of z to the 7 minus 1 is equal to 0. So the real root of that is just this, which is 1, and passes through the point represented by cis 2 pi on 7. So that's just going to be sketch the ray that originates at the real root. So you're going to have open circle here, and passes through that point is there. Find the equation of the ray in the form arg z minus z0 is equal to theta. So if you just kind of draw like a, first of all, this is the starting point, z0 is equal to 1, and then the angle, you basically want to know this angle, right? So what you might do is, you know that this has a length of 1 and it's got an angle of 2 pi on 7, and this has 1, so this also has 2 pi on 7. So this is 180, or pi minus 2 pi on 7, which is 5 pi on 7. It's 1 mark. So this is arg z minus 1 is equal to 5 pi on 7, I believe. And we can check that because, yeah, that makes sense because it's parallel to this line, which is 1 pi on 7, 2 pi on 7, 3 pi, 4 pi, 5 pi on 7. So that's nice. Alrighty. So I'll just leave only what they wanted me to sketch. Oops. And we'll move on. Verify that the equation z minus 1 is equal to 0 can be expressed in that form. That's going to be horrible, but we can expand that. So z to the power of 7 plus z to the power of 6 plus z to the power of 5 plus z to the power of 4 plus z to the power of 3 plus, I should have said, let's say that's a. That means a is equal to that. Oops. Plus z squared plus z. And that's equal to 0. Sorry, I forgot to do the minus z to the power of 6 minus z to the power of 5 minus z to the power of 4 minus z to the power of 3 minus z to the power of 2 minus z to the power of z, and then minus 1 equals 0. So that cancels, that, and you have, therefore, z to the power of 7 is minus 1 is equal to 0. Express cis 2 pi on 7 plus cis 12 pi on 7 in the form a cos beta b pi, where m be an element of positive real numbers. So this is just cos 2 pi on 7 plus cos 12 pi on 7 and then plus sine 2 pi on 7 plus sine 12 pi on 7 all multiplied by I. Now, what can we say? So 12 pi on 7 is like saying we're all the way in the, which quadrant? It looks like about here. So I'm just going to say I'm going to go in the opposite direction and go 2 pi minus, because that's not in its principal form. So that's going to be negative 2 pi on 7, right? So negative 2 pi on 7. Now, that is 2 cos 2 pi on 7, because the cos, that negative goes away. But this one comes out, and this cancels. So it's just 2 cos 2 pi on 7. Given that w is equal to cis 2 pi on 7 satisfies that equation, use Demoivre's theorem to show that those three equal to negative 1/2. Okay, that's a little bit weird. But w is equal to cis 2 pi on 7 satisfies that equation. Use Demoivre's theorem to show that those sums is equal to negative 1/2. Okay, so this is basically w squared, this is w, and this is w cubed. So that makes up like that part there. And the rest are the other solutions. But if you say, there's actually some symmetry here, because if you divide this by, let's divide everything by 3, 3, 2, 1, 0, then you subtract, so 3, 2, 1, 0, negative 1, negative 2, negative 3. So actually, you can say that z to the 6 plus z to the 5 plus z to the 4 plus z cubed plus z squared plus z plus 1 is equal to 0. And then you can divide by z cubed. That means z to the power of 3 plus z to the power of 2 plus z to the 1, or just z, plus 1 plus z to the power of negative 1 plus z to the power of negative 2 plus z to the power of negative 3 is equal to 0. Now if you look, these are just to the negative powers, and that's equal to negative 1. So this, so you can say that that's cis 6 pi on 7, 4 pi on 7, 2 pi on 7. So that's 2 pi on 7 plus cis 4 pi on 7 plus cis 6 pi on 7. And then plus cis negative 2 pi on 7 plus cis, this is so long, for 2 marks this is a bit ridiculous. What was I up to? Cis negative 2 pi on 7 plus cis negative 4 pi on 7 plus cis negative 6 pi on 7, and then don't forget you've got the plus 1 is equal to 0, or equal to negative 1. Now, if you say the real part, so wait, first of all, this is cis, what is it? If you add 2 pi you add 14, so that's 12 pi on 7 plus cis 14 pi on 7, 10 pi, sorry, 10 pi on 7 plus cis 8 pi on 7. And we've just shown that the opposites are the exact same. Oh, no, we don't even need to convert to that. We just know that the causes double up, right? So we know that 2 times cos of 2 pi on 7 plus, when we have the negative, they double up, as we just showed here. 2 cos 2 pi on 7 plus 2 cos 4 pi on 7 plus 2 cos 6 pi on 7 is equal to negative 1, 2, oh, I hate writing this expression, is equal to negative 1, and therefore this expression, which I'm just going to say is b, because I said a for something else, is equal to negative 1/2. Okay, that's a hard question. That is a pretty hard question. The curve given by y squared is equal to x minus 1, where that is rotated about the x-axis to form a solid revolution, write down the definite integral. It's rotated about the x-axis, so pi times the integral from 2 to 5 of y squared dx, so x minus 1 dx. And the volume of this solid revolution, I'm just going to chuck that straight in the cas. And you get 15 pi over 2 units cubed. Express the surface area of the solid in the form pi times that, where all of these are positive integers. And the formula for the surface area is around the x-axis. It's pi times the integral from x1 to x2, so 2 to 5 of sorry, no, it was 2 pi, and then times by x, no, was it y? No, it's y, and then times by the square root of 1 plus dy dx squared. So dy dx is what is it? That's a bit annoying. So this is, you can say 2y dy. Actually, I don't want anything in terms of x. So I'm just going to say this is the square root. It's the positive square root because it's from 2 to 5, so it's positive. So x minus 1. And the derivative of that is 1/2 x minus 1 to the power 1 over 2 square root x minus 1. And that's all squared. So that's 1 over 4 times x minus 1 dx. Now this is the square root of x minus 1. And so you've got, it just wants the pi on the outside. You can multiply the inside, so you've got x minus 1 minus 1/4, and then you've got a 2 there. So that's pi times the integral from 2 to 5 of the square root of 4x minus 4 minus 1 to 4x minus 5. Now I'm just going to confirm that on the CAS because that was just a lot of algebra in my head, and that's, don't forget your dx's. So let's just check that the integral from 2 to 5 of the square root, what was my initial expression? Square root of x minus 1, and there's a 2 pi here, times by the square root of 1 minus 1 on 4 times x minus 1. Okay, well, it gave me that, but let me just say that that's equal to pi times the integral from 2 to 5 of the square root of 4x minus 5. Please say true. True. Cool. Hence, otherwise find the curved surface area of the solid correct to 3 decimal places. So we just need to do this, and that's 27.698 units squared. The total surface area of the solid consists of the curved surface area plus the areas of the 2 circular discs at each end. Yes, we know that. The efficiency ratio of a body is defined as its total surface area divided by the enclosed volume. Find the efficiency ratio of the solid of revolution correct to 2 decimal places. So it's this 27.698 is the surface area. Then you need to add the 2 circular discs at the start. So pi times 2 squared plus 25 pi, because if you think about it, you're basically rotating something like, I don't know, this around, and the radius here is 2, the radius here is 5. You need to add those surfaces there, these circles, which and then divide that by the volume we found, which was 15 pi over 2. Now that is this plus 4 pi plus 15, it's 25 pi over this. If it would copy, I'll just type it 15 pi over 2, and that is 5.04. And they only want 2 decimal places. Another solid revolution is formed by rotating the curve given by that about the x-axis for 2 to k, where k is an element of real. The solid has a volume of 24 pi. Find the efficiency ratio. I feel like they're just asking this question for the sake of it. Like there's no... Okay. So, the volume, so pi times the integral from 2 to k, y squared dx, so x minus 1 dx is equal to 24 pi. And that means you need to find k on the CAS. So what I'll just do is a menu 3-1, and don't bother typing that again. Just go up here, change that to a k, and you can also get rid of that and just equal to 24, comma k. K is -6 or k is 8, and of course k is greater than 2 because it's from 2 to k, and they wouldn't say 2 to -6 in that order. So k is equal to 8. Right, now you want to find the surface area, which is 2 pi times the integral from 2 to 8 of it's the same expression on the inside, which is 4x minus 5, square root 4x minus 5, dx, plus 4 pi plus 64 pi all over its volume, which was 24 pi. Just want to check that. So it's 2 pi. Oh, I made a mistake. It was the two went inside to give that. So it's just pi times that, I hope. And let me put that on the here. So I'm just going to enter this down. Plus 4 pi plus 64 pi. Then it was over 24 pi. Oops. And I'm just going to delete this and put in another integral, which is one we've already done before, and change that to 8. And the efficiency ratio or whatever is 3.77 to 2 decimal places. So that's that question. Now we have our lovely differential equations question. A fish farmer releases 200 fish into a pond that originally contained no fish. The fish population, P, grows according to the logistical model, that where T is the time in years after the release of the 200 fish. The above logistic differential equation can be expressed as that. Find the values of A and B. So this is just saying T. Alright, so I feel like we could just do this by hand a bit. So dt over dp is equal to 1 over p times 1 minus p over 1000, right? That means the integral of dt is equal to the integral of 1 over p times 1 minus p on 1000 dp. Now, I'm guessing here they just want you to do the partial fractions, which we will do on the CAS. If you just do menu 3 expand and you put 1 on p times by 1 minus p on 1000. And you've got 1 over p minus this. Now, if you just do it, you know what you can do? You can do a solve. This is equal to 1 on p, so it's obvious the first one is 1 on p, and then plus, and you can say in the form that they want. So, but you want to solve for b. I've got b defined as something, so I'll say d. 1 on d on 1 minus p on 1000, and solve for d, and d is 1 on 1000. Yeah. So it's 1 mark, so a is 1, and b is 1 on 1000. I think, yeah. One form of the solution for p is equal to that, where d is a real constant. Find the value of d. Alright. So we probably want to solve this differential equation. What you can do is there's a differential equation solver here. So the equation is p dash is equal to p times by 1 minus p on 1000. The independent variable I forgot which one's independent and which one's dependent. The independent is P, I believe. The dependent is T. And condition 200. So y of 0 or P of 0 is equal to 200. What did I do? Argument error. Maybe I switched the dependent and independent. Ah, there we go. So 1000 e to the power of t over 1 plus d e to the power of negative t. So they want you to divide this by, so again we can do the exact same thing to get the form that they want. So solve what the CAS gave me to give me 1000 over 1 plus d times by e to the power of negative t, and solve for d, and d is 4. The farmer releases a batch of n fish into a second pond. Pond 2, which originally contained no fish. The population Q can be modeled by that equation. Find the value of n. Where's n? Oh, n fish. Okay, so the farmer releases a batch of n fish into a second pond, pond 2, which originally contained no fish. The population Q of the fish can be modeled by that. The population Q of fish in pond 2 can be modeled by that, where t is the time in years after n fish are released. Fish farmer releases 200 fish into a pond that originally contained no fish. So it grows, and then do we need to find the intersection point? I'm pretty confused here. We just sub in t is 0. So 1000 over 1 plus 9, which is 10, which is 100. Find the value of q when t is 6 to the nearest integer. So 1000 over 1 plus 9 times e to the power of, is that negative 1.1? I can't really see, it's a bit blurry, but negative 1.1 I hope, times by 6. It's 987.904. So 988. I think that's right. Yeah, I think that's 1.1. Yeah, that is 1.1. Okay. Given that dq over dt is equal to that, express d squared q over, so the second derivative of q. So dq over dt, d squared q is equal to, now you can do u is 11 q, 11 over 10, then multiplied by dq over dt times by 1 minus q on 1000. So that was just differentiating this implicitly, then plus Now you keep the you diff the second, but you keep the first. So 11 on 10q times by negative 1 on 1000. Okay. So negative 1 on 1000 times by that, and then don't forget dq on dt. So what you can do is now just go on the CAS and you can sub in dq over t and all of that and get it in a simple form. So what I'll do is I'll define f of q as, this is what I'm saying is dq over dt. Or you can say d of q if you like to make it easier. So derivative of q. Now that's 11 on 10 q times by 1 minus q on 1000. Right, so that's your derivative. Now we said that our d squared t was 11 on 10 times by dq dt, so times by d of q, times by this thing here, then minus 1 on 1000 times by 11 on 10, and then times by q, and times by d of q. Alrighty, that looks rubbish, but I'm just gonna go with it. So 121q times q minus 1000 times q minus 500 all over, is that 5 million? That can't be 50 million. How many zeros is that? 1, 2, 3, 4, 5, 6, 7. So that's 50 million. 6 zeros right there. Okay, well, I guess I didn't really make a mistake, did I? Well, I hope not. Hence or otherwise find the size of the fish population in pond 2 and the value of t when the rate of growth of the population is a maximum. So you're solving, so what you're finding when the rate is a maximum. So you solve d squared q over dt squared is equal to 0. And so menu 3, 1, this is equal to 0, comma q. So it says give your answer for t correct to the nearest year, but it doesn't say anything about q. So q, okay, so these look kind of nice. We just want to know which one's a maximum and which one's a minimum. So first of all, I'll write out the 3. Might get working out marks here. Q is equal to 0, q is equal to 500, and q is equal to 1000. And you just need to see which ones to reject. So just plug them into here. I don't think it'll be q is 0, but just to check, it's 0, definitely not. So then you can try the 500, that's 0, and the 1000. I subbed it into, I should have subbed it into d of q. So 0, 500 is 275, and what was the other one? 1000 is 0. So okay, so q, you reject the 1000 and the 0. So q, I should have written it as a capital. Also for this previous part, I should have written it as capital Q's, just because my CAS. And these as well, q, q, q. So q is equal to 500, and you can solve for t when q is 1000, q is 500, sorry, they gave you the differential equation, which is there. So it must be, you just sub in and solve for t. So menu 3-1, 500 is equal to, and I'm sure I've written that equation somewhere. Here it is, and that's just t, comma t. T is 1 to the nearest integer, t is 2 years. And it goes on. Sketch the graph of q versus t on the set of axes below. Label any x-intercepts and any asymptotes to their equations. Alrighty. So let's just go to the CAS. Now I'm just going to define q of x. Of course I can't use t on the CAS, so I'm just going to do that and change the t to an x. Now I'm going to go to the CAS. I'm going to sketch that in. Get rid of this slider from before. And this one was from the multiple choice. Q of x, and let's just press enter. What happened? So t is negative, that doesn't make sense. Did I put the negative 1.1? Yeah, I think I did that right. What have I done? Does this start at 0? Ah, it does, okay. So I'm just gonna, what I'll do is I'll go t is greater than 0 in here. Sorry, x. And then what I'll do is I'm going to make my window the exact same as what they've given me on the sheet, on the page. So window settings, they've given you from 0 to 6, I'll go from -1 to 7. And the scaling they've used is they've gone up by 0.2. Now the y minimum have gone from 0 to 1000, so I'm going from -100 to 1100, just a bit before and after. And the x scale they've gone up by 50, 100, 150, by 50s. And it should look quite nice there. Now it doesn't say, it says it goes on forever basically. Alright, there is an asymptote, and the way you can find that asymptote is you just look at this equation. As this goes to infinity, as x goes to infinity, or t, this goes to 0. So it's just 1000 is the asymptote. So you can draw that asymptote like that. And keep in mind, don't write y, write q is equal to 1000. And the starting point we found, which is on t is 0, and that was 100. So it says label any x-intercept, so that's 0, 100. And then you probably want an inflection point. We can find that here. So analyze graph, inflection, and it was of course here. So the 1.997, or about 2, and it was 500. So 500 is here, and 2 is here. So that's our inflection point, and it looks something like that. That's all. Surprised they ask these questions the sketch questions. They don't usually ask you to sketch things on exam 2. They did it in the methods exam 2 as well this year. So maybe they're starting to do that a bit more. The farmer wishes to take 5.5% of the fish from pond 2 each year. The modified logistic differential equation that would model the fish is that. Find the maximum number of fish that could be supported in pond 2 in this situation. So, if it was 5.5% of the fish from pond 2 each year, the modified logistic differential equation. So I'm guessing it's just 5.5% of 1,000, but I don't want to take that as my answer. Oh, so he's just taking that away, the maximum number of fish that could be supported. Yeah, it's just going to be this 1,000 minus... Oh, he wishes to take 5.5% each year. The modified logistic differential equation that would model the fish population Q in pond 2 after T years is that. Find the maximum number of fish that could be supported in pond 2 in this situation if he takes 5.5% of fish each year. So isn't it just 1,000? Isn't that just when the rate is 0? Actually, I'll just solve the rate is equal to 0 just in case. No, it's not 1,000. We basically had d of q, which I just want to make sure is defined right. Yes, this here minus, and q is defined as something. So I'm just going to say, okay, I'll just delete variable. And solve. This minus 0.055q is equal to 0, comma q, 950. Okay, differential equations question done. 2 more questions. The points with the coordinates that, and that all lie in plane pi. Find the vectors a, b, and ac, and hence show that the area of triangle ABC is. So AB is just OB minus OA. Now that is 1 minus 1. It just says find, so I don't need to do much. So that's just 0i, so plus j, 2 minus 1k, plus k, so it's just j plus k. Now AC is equal to c minus a, so that's 2i, plus j, plus 2k, I think. Well, we'll check if that's right if we get this 1.5. Now, the area of the triangle, so I'm just going to say a triangle, that's equal to the the magnitude of the cross product of AB and AC, and if it's a triangle, it's going to be half of that. Because remember, if we have the magnitude of the cross product, that gives you the area of the parallelogram. So if you half that, you get the triangle. So I'm just going to go straight to the CAS and do norm cross P, and the first vector was just 0, 1, 1. The second vector was 2, 1, 2. And that gives you 3. So you can write 3 over 2, which is 1.5. Nice. Find the shortest distance from the point B to the line segment AC. So AC that is, we found that that's the direction vector, so you can say t times 2I plus j plus 2k, and it contains the point A or C, so you can say I plus j plus 2k. So that's your line segment AC. Now if you have the point B, so that just looks something like that, and point B is just sitting right here. If you want the minimum distance, you can do a perpendicular vector to that. So yeah, you just want the, you take any point, which let's just say this is A, and this, so that, and this is B. So it's AB in the direction of the perpendicular vector, right? So AB is going to be A minus B, which is negative I minus j, sorry, negative j, because the I is 0, minus k. So that's that. Now you want negative j minus k, you want to dot that with the unit vector in that direction. So we don't know what this is, but we want that, so let's say it's x, y, z. X, y, z minus b, we want that to have a dot product with that to be equal to 0. Right? So it could be pretty much anything, but we can choose. So we want x minus 1 times 2 plus y minus 2 times by 1 plus z is 3, so z minus 3 times 2 to be equal to 0. So you can just take x to be 1, y to be 2, and z to be 3. So 1, 2, 3. And that is point B, isn't it? What have I done? Oh, and it has to lie, it has to be on this line. So this is not x, y, z. It's 1 plus 2t, 1 plus t, and 2 plus 2t, and 1, so the dot product of this minus this, and this has to be 0. So let's just solve on the CAS. Dot P of now it's 1 plus 2t minus b, which is 1, comma 1 plus t minus 2, comma 2 plus 2t minus 3. So that's the vector, the normal vector, and dot, so comma 2i 2 1 2, that's equal to 0, and solve for t. Oops, too many arguments. What have I done? Oh, I didn't put that in a solve. 2, 3, 1. This dot p is equal to 0 comma t. So t is 1/3, right? So that's giving you the value here. So now you can get this vector when t is 1/3. So that's your normal vector. You want the scalar resolute of negative j minus k in the direction of this vector. So you can do the dot product of this. So I'll say the other one, which was negative j minus k. So I'm going to enter this, and I'm just going to put 0, negative 1, negative 1, so negative j minus k, comma, the unit vector of this. And that gives you 1. That was long. I probably did it a really long way, but this is the new content, so that's alright. So yeah, I'm just gonna, as my working out, I'm gonna say 2 over 3 minus so I minus 2/3 j minus 1/3 k all over the magnitude of that, which you can write that out. That's whatever, and it's equal to 1. Yeah, you can write this out. I just can't be bothered. A second plane epsilon has the Cartesian equation 2x minus 2y minus z is equal to negative 18. At what acute angle does the line given by that intersect the plane pi? So, if you think about it, this is a line, right? And it would pass through the plane. I've drawn it a bit horribly. So, I don't know, something like that. And let's say it pierces through there, and you want to find the angle. So what you can do is you can find the normal vector to that plane. And that's what you've got here. So normal vector is 2i minus 2j minus k, right? Now you can do the dot product, the cos inverse of 2i, so the dot product of that and the direction vector of the line. Dot I minus 2j plus 2k all over the magnitudes multiplied, so square root of 4 plus 4 is 8 plus 1 is 9, so 3 times by 3, right? And that's giving you this angle there. So if I do, and go in degrees, cos inverse or arc cos, and you've got the dot p, so I'm just going to use this again on the top, and I'm just going to change it, so 2, negative 2, negative 1, which is fine, and the other one is not a unit vector anymore. It is 1, negative 2, I've stuffed this up, so 1, negative 2, 2, right? And that's over 9. So that gives you 63.61. But remember, that is this angle here. So you need to subtract that from 90 to get this angle. So 90 minus this is 26 point to the nearest degree, 26 degrees. So just write 90 minus there. A line passes through the origin and is normal to the plane epsilon. The line L intersects epsilon at point D. So at a point D. Write down the equation of the line in the parametric form. So a point is the origin. So L is 0 plus t times and it's normal to the plane psi, so you've literally just got this 2i minus 2j minus k. So you don't need that 0, and that's your thing there. Find the shortest distance from the origin to the plane epsilon. So I'm assuming they've asked you this for a reason, and this goes from the origin to the plane. So you just need to find the intersection point between this and the plane, and then you can find the magnitude of that point. So yeah, so what's the point of intersection? 2t, you can plug that into here. So 2 times 2t, so that's x, minus 2 times, now y is negative 2t, and then z is so minus z, which is negative t, and that's equal to 18. So you can solve for t. So menu 3.1, 4t plus 4t plus t is equal to 18. That just means t is equal to 2. So t is equal to 2, so you can now get the point just by subbing that back into there. So it's 4i minus 4j minus 2k. And then you can just find the magnitude of that. So that's the square root of 16 plus 16 is 32 plus 4 is 36. So it's just 6 units. Alright, and find the coordinates of point D. What's point D? The line L in the plane. We just did that, so you can write your working out again. So you can solve 2x minus 2y minus z is equal to negative, was it negative 18? Whoops, I did 18. So it should be negative 2. So t is negative 2 here. And then that just means that you've got negative of this whole thing. So negative whatever. But the magnitude stays the same. So negative 2t, 4i, plus 4j, plus k. And so that's 6 units. And that's d, but yeah, you can write it out. You can write that's negative 18. And then you can say x is equal to 2t, y is equal to negative 2t, and z is equal to negative t. This is a pretty stupid question because most students, or a lot of students, will do it this way, and then you've gotten yourself 4 marks for a 2-mark question, which, yeah, I don't know. It should have been find D first and then a 1 marker for part E. Yeah, that's what it should have been, because you can use that coordinate of D to find the distance. But anyway, if you sub that in, you just can say t is equal to negative 2, therefore D is equal to negative 4, I don't need brackets, negative 4i plus 4j plus k. Final question, which is the probability question. A forest ranger wishes to investigate the mass of adult male koalas in a Victorian forest. A random sample of 20 such koalas has a sample mean of 11.39. It is known that the mass of an adult male koala is normally distributed with a standard deviation of 1.5 or 1.1. Find a 95% confidence interval for the population mean, which is the mean mass of all adults koalas in the forest. So that's just x bar, sorry about that. That's just x bar minus 1.96 times the standard deviation, which is 1 on square root of n, which is 20, and then x bar plus 1.96 times 1 on square root of 20. And I'm just going to chuck that on the CAS. The sample mean was 11.39 plus 1.96, sorry, minus first, times by 1 on square root 20. Now that's your lower bound, which is 10.95. And then your upper bound, just enter that down and put a plus there. And that's 11.83. 60 such random samples are taken and their confidence intervals are calculated. In how many of these confidence intervals will the actual mean mass of all adult male koalas in the forest be? So you expect 95% of such confidence intervals to contain the sample mean. That is a textbook definition that you should memorize. So 95% of 60. So 0.95 times 60. And that is 57. The ranger wants to decrease the width of the 95% confidence interval by 60% to get a better estimation of the population mean. How many adult male koalas should be sampled to achieve this? So the width is how much? The width is 11 point, so the width is this minus this, which is that. So that's the width, and you want that to decrease by 60%. So in other words, that times 40 or minus 0.6 times by this. So you want it to be that. You want it to be 0.3506. So in other words, first of all, you can say your margin of error, or you don't even need to do anything here. What you can just say is the margin of error, you want to multiply by 0.4, which is 0.4, and in order to do that, you have z times the standard deviation on square root of n. So if you multiply that by 0.4, that's the same as 4/10 or 2/5. Now that goes in as 25 on 4. So you need to multiply n by 25 on 4. N was initially 20. 20 times 25 on 4 is 125, which is a nice answer. It is thought that the mean mass, so finally they're starting the alternative and whatever. It is thought that the mean mass of adult male koalas in the forest is 12 kilograms. The ranger thinks that the true mean mass is less than this and decides to apply a one-tailed test. A random sample of 40 adult male koalas is taken and the sample mean is found to be 11.6. Write down. So H0 is that the mean is equal to 12, and H1 is that the mean is less than 12. The usual. The ranger decides to apply the one-tailed test at the 1% level of significance and assumes the mass of adult male koalas in the forest is normally distributed with a mean of 12 and a standard deviation of 1. Find the p-value for the test corrector for. So p is equal to the probability that x bar is less than what he found, 11.6, given that the mean is 12. I don't even know if the CAS has a p-value function. It probably does. Probability or statistics, stat tests. I don't know. I'm just going, stat calculations. I don't even know what it is. That's all right. So, the z value is going to be x minus the mean, so 11.6 minus 12 over the standard deviation, which is 1 and how many did 40, so 1 on square root 40. So that's your z value. Oh, okay, I think this is common value. I think it's the 99% or something. Anyway, probability, distributions, norm, CDF, and you want from negative infinity to this negative 2.52. Oh, it was 529. Okay, what I'm going to do is enter that down there. 0.05, so they want it to how many decimal places? To 4. So 0.0057 is your p-value. And draw a conclusion about the null hypothesis. So since p is less than 0.01, is that? Yeah, that's less. We reject H0. And the sample, the actual mean mass should be lower or less than 12 kilograms or something like that. What is the critical sample mean, the smallest sample mean for H0 not to be rejected in this test? Give your answer in kilograms correct to 3 decimal places. So here you're just saying probability that x bar is less than your critical, given that the mean is equal to 12, is equal to 0.01. Now, first of all, we just do an inverse normal. Menu 5, 5, oops. Menu 5, 5, 3 for inverse normal, and the area you want to be 0.01. That's your z value. And so you can solve for your critical value. This is equal to x critical, I'll just say x, minus the mean, which is 12, over the standard deviation is 1 on square root 40. And you're solving for x, which is 11.63, how many decimal places? To 3, 11.632. Cool. Last two questions. Suppose that the true mean mass of adult male koalas in the forest is 11.4 kilograms and the standard deviation is 1. The level of significance of this test is still 1%. What is the probability correct to 3 decimal places of the ranger making a type 2 error in the statistical test? So, what is a type 2 error? A type 2 error is when you keep H0 and you should have rejected it. So you found the critical and you're saying what's the probability that x bar is greater than your critical value, because that's when you keep it, given, so you keep it when it's greater than that, given that the actual mean is 11.4. So again, we're going to go to the CAS and we are going to use this same thing here, but instead of 11.6, we're using 11, this value here. And the actual true mean is 11.4. And standard deviation is 1, so everything is the same. So that's the z value, and you want the probability that it's greater than this. So menu 552, and I'm just going to put in a certain value. I can't remember. The reason why is because I don't remember the value, but you can enter it down after. The upper bound is infinity, and it's a standard normal, so enter that. Now here you just want to use the value that is fully here. So it is 0.07 to 2 decimal places, to 3, 0.071. Correct to 3 decimal places. The frequency curves for the sampling distributions associated with H0 and H1 are shown below. Label the critical sample mean on the diagram and then shade the region that represents type 0. So I think this is where they made the mistake, and I've heard that they switched the labeling up of H0 and H1. So let's see. So H0 has the mean. So H0 should have the mean of 12, and H1 should have the mean of 11.4. So that's wrong, and I don't know if I think they should award everyone that mark. I don't know if they will, because they did say that H0 had a mean of 12. Vika can be a bit stingy, so I'm not sure if they'll award everyone the mark there. But anyway, label the critical sample mean on the diagram and shade the region that represents the type 0. So the critical sample mean was 11.632. So these are going 11.6, 7, 8, 9, 12. So 11.63 is about there. Now I'm just going to XC, this is critical sample mean, and shade the region that represents the type 2 error. So type 2 error is the probability that it's greater than this, given that the mean is 11.4. The true 11, where's 11.4? Yeah, I think that's it. That's 11.4. Yeah. So that should be the shaded area. So that is the special exam 2. I think it wasn't bad at all, except for the multiple choice. The multiple choice was a little bit long and tricky. They asked some new questions. There was also that complex numbers question, which was a little bit tricky as well. It was a show that question, so I guess if you kind of wrote anything out and ended up with it being -1/2, you might have gotten the marks. But apart from that, it wasn't too bad at all. But yeah, good luck to everyone for the rest of the exams. Hope you did well.